Well, we're out in the backyard and look at that aurora. Now, I've got to be way up north to see aurora like this, okay? But the moon's not out and I can see Jupiter, Saturn, all kinds of wonderful starry sights up there as we welcome you to stay star curious at the American Space Museum here in downtown Titusville. I'm Marquette, and we're so glad that you joined us today as we're going to talk about how the sun has and will affect communication systems on Earth during these cycles when the sun gets hotter and more active. Active meaning throwing off some of its plasma from its nuclear fusion that's going on there. And we're going to talk about aurora a little bit, but there's several other phenomenon that I find it interesting. One in particularly named Steve, that we really don't know where it came from and why it happens in our sky. So there's always things to learn when you're looking up, and that's why we're glad that you're with us today. Also with us today is Marty Winkle, my co-producer. Marty, how are you? I understand you were a volunteer at Family Day at Kennedy Space Center over the weekend. How'd that go?
That really went well. Uh, I took Connie McDaniels and Bill Whiting and Tammy Miller out there, and they just had a great time. It's one of those once in a lifetime things for them. Walking through the VAB, going to LCC, getting your picture taken with Charlie Blackwell Thompson, driving out onto the shuttle landing strip, seeing where STS 135 wheel stop occurred. It was just a great experience.
Wonderful, wonderful. Yes, it's always I had one time a privilege to be out there like that. Like you said, it may never happen again. I was tied up with an event that we were doing with the Museums of Brevard, or I would have been happily there with y'all. But yeah, Connie McDaniel, one of our ace volunteers, and Bill Whiting. Also, we thank you for all that you do, Bill. Uh, I bet they had their eyes wide open looking at everything out there, Marty. I understand you even went out to the a bus tour and they went out to the shuttle landing strip and saw wheel stop and all that.
Right. Yeah, they
Cool.
went out to uh, 39A, pad 39A.
Oh, really? The SpaceX pad. See the new Starship gantry going up, all that stuff. That had to be interesting. Well, we'll try to show some pictures maybe throughout the week of that from those volunteers of ours. I know Connie shared some, and we'll to give you behind the scenes out there. Just didn't have time to rack them up today because busy day with all of the things we've got going on. So let's get our publicity out of the way. Our Galaxy of Giving campaign is going to kick off tomorrow, but our friend Dave Stange kicked it off already. Dave Stange he's 65 today. Welcome to Senior Golden Life there, Dave Stange. He's up in Michigan area, up there, a big University of Michigan fan. And Dave, happy birthday to you. And he gave us $65 to celebrate his birthday, Marty, to specifically be used on Stay Curious. And we're going to put your star in the constellation of giving there, as he's given more than that throughout this 4 years that we've been friends together through Stay Curious there. Dave Stange, his friend Larry Pushkar, and Bill Whiting, all are from that state up north from where I grew up. Of course, the great state of Ohio. And Marty's from Long Island, so he trumps everybody there. So, but our Galaxy of Giving is no joke. We need money to support our nonprofit, and you can get a tax deductible donation by giving to us. And we're going to offer several levels and let you pick some of the swag that you want to be given. We've got astronaut autographs. We've got some Skylab stuff we're going to be giving away for your financial donations. So thank you, Dave Stange. You mean a lot to us, brother. And he's been in our museum several times. We'll show his picture here in a day or two. And his granddaughter's our youngest fan, Marty. Space Memorabilia Show this Saturday. I just booked at it. What was I going to say? Not, well, we've got the patch guy. Okay.
Good.
Tim Gagnon's coming. I wasn't thinking of Tim. I was thinking of, who am I thinking of that's an artist? Anyway, he'll come to mind. But the patch guy is Tim Gagnon. He will be set up there to say some of his patches. He literally has a couple dozen of them floating around on the walls of the International Space Station up there. And we've got, I want to say Keith Richards, but that's not right. It's Ken Havocott, one of the world's renowned memorabilia experts, will be there. He, in fact, is sponsoring our major expenses there. God bless you there, Ken, for doing that. Bid Again Auctions with Chuck Jeffrey will be there. And also Computers for Education. We couldn't do without them. They give away computers to kids and nonprofits like us that they recycle from other businesses out there. So it's very, we're gonna have a lot of fun. This is our second annual memorabilia show. We hope this grows into astronaut autographs and some things like that down the road. But we're doing what we can to present this, and it'll be at the Beachside Hotel and Suites there on A1A, right beside Ron John's, across from IHOP if you've eaten out there. And we've got 2 autograph sessions next week. November 16th is with legends Jack Lausma and Rusty Schweikert, both trained for Apollo missions. Schweikert on Apollo 9 as the lunar module pilot. Lausma was a backup, and then he was on Skylab for 28 days, and then spent, I think, 5 or 6 days in space on STS-3, the only one that landed out there at White Sands, Columbia's 3rd mission up there. So autographs, you have to be here and be in line to get that autograph. We're not doing anything over the lines or internet. There's not enough time for that. $100 for one autograph, $160 for the pair. Yes, Marty.
Yeah, Carlton Bailey is thinking you mean Ron Woods. Is that correct?
I do mean Ron Woods. Thank you. I said Keith Richards because I was thinking of a guitarist for the Rolling Stones. Thank you for my senior moment. Carlton Bailey will be there selling some of his real cool stuff. Yeah, bring a few Godzilla things. After all, Godzilla's birthday was last week, November 3rd, 70 years old. But yes, Ron Woods. Talked to Ronnie today, in fact. And he is a white room tech that suited up the Apollo astronauts, including Buzz and Neil. And Chris Callie's dad, Paul, took sketches of that. It's so cool to put that picture together of these space workers that have become artists. So thank you, CB. We've had a great picture that Carlton took from his yard about 30 miles away of a nice streak of the launch we had the other night, Friday night, in fact. So Nicole Stott will be here to sign her book November 18th, 1 to 3. Return to Earth, and then she'll be at the Rocket Ranch reunion that evening, and some of us are going to have breakfast with her, courtesy of the Astronaut Scholarship Foundation. So you take part of that. There's the DVD, Searching for Skylab, America's Forgotten Triumph. All these astronauts are involved in it, and so is our friend Emily Carney. And Emily Carney will be in the building, Space Hipsters #1. Well, let's get 3 birthdays that happened on November 5th on Sunday. And these, we like putting them on Facebook and then acknowledge a belated birthday. We have got Bob Senker was 75, Charles Scorch Hobaugh was 62, and Alvin Drew is 61. And let's look at their smiling faces there. Now, there's Bob Senker on his one and done launch in 1984, I believe. He was born November 5th, 1948 in Mellon Township near Pittsburgh, Pennsylvania. He was a payload specialist for 61C, worked for RCA, much like our friend Charlie Walker that went up with his company's satellite. Well, this was the final mission before the Challenger disaster. So that's why he didn't fly again. He didn't wait 2.5 years, and then you're thinking about it, gee, I can have a good career here with RCA, which he did. He's a Penn State and Rutgers graduate, earning 2 Master of Science degrees in that. So here he is out the Space Center not too long ago. Bob Sinker, we wish you a happy birthday, 75 years old. Then this guy, Charles Owen, and his nickname is Scorch, Hobaugh. Hobaugh was born in Bar Harbor, Maine, and grew up in North Ridgeville, Ohio. So he's an Ohionaut by proxy. A graduate of the U.S. Navy Academy, he flew on 3 shuttle missions. He was a pilot on 2 and a commander on 1. 104 and 118 he was pilot, and he was a commander on 129, accumulating 36 days in space. And you would hear Hobaugh's voice on the fateful 107 re-entry disaster. He was the Capcom on talking to the crew, waiting to hear them come out of the plasma of re-entry, and he was saying Houston, Columbia, Houston, UHF com check several times after they realized that they'd lost contact with their friends. So there's Hobaugh at the mission control. I think he still involved in NASA in some capacity, though not as an astronaut there. And then also born on November 5th is Alvin Drew. Benjamin Alvin Drew, born November 5th, 1962 in Washington, D.C., grew up in Brooklyn. He was a second lieutenant in the Air Force. For years, he was the last African American to go to space on STS-133, that flight with the Discover orbiter. And Victor, what's Victor's last name? He was the next African American to go up. He is pilot of Artemis II, Marty. Glover, Victor Glover. Victor Glover. So there was about a 10, 11-year gap between flying African Americans in space, sadly. He performed 2 spacewalks and the 200th human to walk in space. And there he is with our good friend Nikki Stott up there on STS-133. So, and he's retired from NASA. So happy birthday to Alvin Drew, Scorch Hobaugh, and Bob Sinker, born on November 5th. Well, we occasionally like to remind people of a thing called a newspaper, and this is the newspaper article that our great volunteer Connie McDaniel gave me the other day. Said that the federal forecasters have announced that geomagnetic disturbances due to increasing solar storms are likely here on Earth and will last through the week. This happens all week, every week, all right, particularly during high periods of solar activity that we're experiencing now. A solar storm is a disturbance in the sun that can affect the Earth and the rest of the solar system, all right? NASA describes coronal mass ejections, CMEs, coronal mass ejections, as huge bubbles of coronal plasma that threatens intense magnetic field lines that are ejected from the sun over the course of several hours, all right? They twist and like an invisible knot. But we're going to talk about just what happens when the Earth is hit by a CMA, and I'm going to bounce to this right there, are sunspots on the sun, okay? And we've talked about that on some Stay Star Curious programs. This is the most important star in our lives. It gives us life. It's actually a yellow dwarf star at 800,000 miles across, all right? If the Earth is 8,000 miles across, so 800 Earths would span from one end to the other of it there, okay? It is huge, and it's 93 million miles away, and it's 800, almost a million miles across. And Marty, why it looks fainter on the edges is because those edges are 250,000 miles away from the front of it, all right? So you have a ratio of light intensity decreased by the sun actually being a 3D object. And that's called the inverse square law of light. Well, these sunspots here are cooler areas that have invisible loops of magnetic energy that are tying those groups up, okay? And these magnetic loops have a lot of energy to them, and sometimes they can like spark, like electricity does, and throw stuff out into space, these coronal mass ejections. Now the sun is a nuclear bomb that's constantly going off, okay? It is a nuclear reaction that's controlled by gravity. That's what all stars are. And how this all happens is still, part of physics that is way above my head, and you don't want to hear all about it, but it's a good career to learn about this. The sun is under 24-hour surveillance on Earth by telescopes, and also about a dozen spacecraft are constantly looking at it. We've got ones that look at the backside, so we can see the solar activity that could flare around. Let's say the one on the left had a big coronal mass ejection out of its system there that spewed stuff into the solar system. Well, it's pointing away from Earth, so it doesn't hit us. It takes about 3 days to go 93 million miles and hit the Earth. So once we see a coronal mass ejection on Monday, we can say, yeah, sometimes Wednesday night, Thursday morning is when it's going to hit. And when it hits the Earth, this electromagnetism comes in through the poles that are magnetically charged in the Earth in our magnetic field. All this invisible energy is really amazing to understand. The sun's surface is about 10,000 degrees Fahrenheit, but the atmosphere around it is 1,000,000 degrees. All right, we don't know why, but all this energy generated at the sun gets hotter as it goes out away from the sun, and like a nuclear bomb. Well, there are several things that happen that I'm going to show you. This is a river of plasma going through the Earth's atmosphere, and this river of plasma is 13,000 miles an hour. This is not aurora. This is something that they call Steve, Steve, and it's a recent discovery. It looks like aurora, but it's not. This soft purple glow is caused by hot rivers of gas flowing through the Earth's magnetosphere at speeds of 13,000 miles an hour. And that's about the speed that an object has to go around the Earth, which is 17,000 miles an hour. They're energized by strong geomagnetic storms like the one that happened over the weekend. And this was observed over Whitley Bay, England. And it lasted for an hour, says the observer. Strong auroras danced in the north while Steve flowed through the sky to my south. All right. There are many unsolved mysteries about this phenomenon that's only been observed for the last few years. Now, why is that? Nobody really knows. Is this a phenomenon just ignored that nobody reported, or is there something happening in the Earth's electromagnetic field and the energy of the sun that's creating this? So another great field to study out there. Well, here's a special look at the sun through hydrogen alpha filter. The sun is 99% hydrogen. So when we look at it, and you don't want to look at it through binoculars or a telescope or anything unless you know what you're doing, you're not going to see the sun like this. It's just you're going to see the sun spots like we saw right here. This is the photographic sphere, the photosphere. This is actually a little bit above the sun. It's so bright that we can't see the surface until we cut through it with a special hydrogen alpha filter. Looks like oatmeal boiling, a granulation to it. All right. And the edges, those red flames, are actually those dark worm marks, filaments we call them, on the surface. Those go over to the edge, and that's what they look like. They look red. These are the areas that are licking off the sun, and any one of these little red flames around the sun are bigger than the Earth. All right, for sure. So you get an idea of the texture, and of course astronomers use different filters to see things, like the Webb telescope is using ultraviolet light and infrared light to see heat registration, not the white light that the Hubble telescope is. And here's another close-up view, an amateur in a backyard observatory. In the observatory, they just haul their telescope out. The sun's so bright and close, we don't need big telescopes to get fabulous images like this. In fact, I'm looking around here. This might be taken with a telescope just like this big, Marty. That's all, because the sun's so close. This is about a 2-inch lens on the end there. That's all you need to deal with the sun and get great pictures like that. Well, that's a sunspot, a lot of detail around it. You see filaments on the edge. On the far left, you see a filament that looks like a cloud. Well, that's really one of these flames on the edge there that we call prominences, solar prominences. So the sun has constantly got this edge of fire around it on there. And you see the oatmeal texture as this million-mile globe is not boiling. There's a nuclear reaction going inside that takes hundreds of years for a photon of light to come out of the center and reach the surface. It's quite an amazing physics, our sun and stars in general. The more we know about our sun, the more we know about stars in the sky. Well, these flames coming off, if a coronal mass ejection would happen, like the one that happened Saturday and Sunday, this can be different levels of intensity, of course. Well, Space Weather is a great website called spaceweather.com, and they said the double blow of coronal mass ejections hitting Earth over the weekend sparked a strong G3 class geomagnetic storm with auroras as far south as Colorado and Texas. The storm is now subsiding with isolated periods of minor G1 class storming expected through November 6th today. Well, and then it'll pack up again. This just happened to hit the Earth at the right angle. Say the sun's rotating 30 days around about, and so one of these could happen and go in the opposite direction from us, or come straight at us. Well, we're going to talk about 5 events that came straight at us over history that have been reported. You might remember a couple of them. But let's first look at this. There's a beautiful aurora coming in. This is up in Norway, I believe. But you get this in the northern latitudes, particularly up where Robert Law is in Ireland. You're going to see these coronal mass ejections could vary the amount of intensity. And this is actual discharging of particles off the sun in our atmosphere. And the colors that are prominent are green and red. And I've even heard people say that there's a roar associated with this sometimes. You can book a vacation tour to see these up in Norway and so forth. It's a popular vacation destination. You can even sleep in an igloo that's all glass. I'd love to do that. Hazel Banks, who's done this, one of our great friends of the museum, and she has done these trips up there. So you can also see him up in Michigan, Dave Stange and Larry Pushkar, when you guys are up there, if you ever have a clear night, that is. But the more northern latitudes of Minnesota and the Dakotas and the state of Washington and all that, and up in upstate New York, the higher the latitude, the better chance you said, but chance of seeing them. But the real severe ones make it down, and occasionally there's been as far as Florida. To see an aurora like this, Marty, would be almost frightening. Excuse me, this is a wide angle lens with a time exposure of maybe a minute. So it's literally like finger painting or oozing colors as they streak across a canvas. Pinks, greens, some purples. And there is this Steve structure. Now those are clouds, but this is a flowing gas through the Earth's magnetosphere at over 10,000 miles an hour. And this was described by the witness who took the picture as an intense purple beam. We could see it plainly with the naked eye, swelling and flickering in brilliance, with delicate structures like those seen within a feather. My mate Connor likened it to a celestial funnel cloud or tornado changing form in real time. Now, to take a time exposure, you lose this kind of, it's said like a feather. You can see details involved in there. And that looks like the planet Jupiter rising on the horizon there. So this is called STEVE, a little known phenomenon that was just discovered. Why we haven't been seeing this for years, I don't know. Maybe it's just something that the Earth and Sun are in a place where something's happening that we don't understand. Well, we do understand that the Sun goes through cycles. Over a couple hundred years, we've known this. This cycle is the famous 11-year solar cycle. From 1900 to 1906, it peaks, and then it drops down to 1912 to the low. And then it comes back up 6 years later in 1918, all right, and then drops down in 1924. To almost no sunspots are visible at these lows. Off my shoulder here is the low that we just experienced around 2010, all right, and now we're up in the middle of this high point in 2023, last 2010, 2023, it repeated again itself on there. This is a well-known pattern. Look at 1960, how the strength of it is based on the sunspot numbers, okay? So one of the greatest sunspot numbers we've ever recorded was in the year 1960, all right? And then it tapered down at the next peak 11 years later. It wasn't almost half as intense. Why this happens, we don't know, but we do know one thing. Our star is a variable star. It's not constant. Things are constantly changing on it, all right? And so when you look at global climate change, you have to include this solar cycle in it. I'd like to know what kind of temperatures were set for highs in 1960, 61, for instance, there. Are those the ones we're breaking now? Well, how does all this electromagnetism in the sky affect the planets, affect the Earth? Well, it can affect the planets as far away as 4 billion miles away, as you see the last 2 solar cycles where the Hubble telescope has been orbiting Earth and looking at the farthest planet, Neptune. All right, a lot of love to Pluto there, but you're the best dwarf planet that ever was. But as you can see, the bright spots are bright activity in the cloud bands of Neptune. And during the low spots, you don't see any. And during the high solar activity, obviously, it matches up with big activity in the cloud bands where solar radiation, even 4 billion miles away, increases enough to light up the clouds on Neptune, where those cloud bands are under 200 they're 200 degrees below zero. So proof that the solar cycle affects Neptune 4 billion miles away, I wanted to say. No, it's actually about 2 billion miles away from the Earth. Yeah. Sunlight takes about 2 hours to reach Neptune at this distance. Well, we're going to talk about big solar eruptions like this one and others that have affected electronics on the Earth. After all, if you got electromagnetic radiation, Marty, it's the electromagnetic static and other things that are going to be affected. All right, just like you hear lightnings crackle, and then you might hear static on your radio. All right, that is the signal of the lightning's energy going through your receiver on your radio. Well, one of the biggest solar events that was ever recorded in human history was in 1859. 1859, all right? So we're talking right before the Civil War. The main way of communication is telegraph. Morse code on that telegraph machine that you see on Wild Wild West and all the great westerns out there. You know, they had telegraph lines of wire all over our country going down to a telegraph machine. Mostly these followed the railways because it just made sense. Well, in 1859, 4 years before the start of the Civil War, on September 2nd, there was observed a solar flare that caused a storm. This geomagnetic storm resulted in widespread auroras, telegraph systems being disrupted, and in some cases catching fire. Catching fire, wires were melted down as they caught the energy, as the metal caught the energy of this solar flare here on Earth. Now, of course, 160 years ago, they didn't have even photography, barely, but they couldn't have photography to take pictures of the sun to see what was going on. And an astronomer named Richard Carrington made sketches of the sun these days, and it showed a massive solar flare like this one, that they call that the seahorse solar flare there, that shape of it. We're looking right down on something coming out of the sun, and there's this black dot is actually the Earth. That's what that black dot right there is the Earth. Well, the Carrington event, they call it, was the most intense geomagnetic storm in recorded history. It was during solar cycle 10, and like I said, there were people that were doing Morse code on the little teletype tickers that got their fingers burnt. They got so hot. The lines were melted down. I've even understood that some of those instruments may have fused together by the intensity of this. Hard to believe, isn't it? Well, then another major, but more recent history. Let's look back at 1972, for example. On August 4th, long distance phone communications was knocked out. What do you got there, Marty? Oh, there's Marty's showing me New York temperature history in 1960. Was at a peak, huh? Yeah, Marty's showing me. Thank you, Marty. There's a yearly chart in 1960.
It's late 50s through 60s.
Yep. How that correlates with the solar. The temperature in New York City, the highs matched the solar cycle highs going on there. Awesome, Marty. Thank you so much for that there. Appreciate that. Our amazing technology. Now, Marty, if we ever hit by a geomagnetic storm like was hit in 1972 or 1989 in Canada, it could melt that machine, quite frankly, I had in my hand. Well, the solar eruption in 1972 knocked out long-distance phone communications across some states, including Illinois. In fact, AT&T redesigned its power system for transatlantic cables. All right. And believe it, 1972, 50-some years ago, we had cables like this thick with wires in them going underneath the Atlantic Ocean, all right, and right down at the bottom of the ocean, 6 miles deep, some of it, and then it came up on the coast of Europe over there, and everybody plugged their phones into those lines over there so they could talk to Europe in 72. Now, this was just the beginning of the burgeoning satellite communications industry, that these noisy rockets here on the West Coast, launching now, 24 of them at a time. Elon Musk has put up 5,000 communication satellites in the last 2.5 years. Guess what? They're all vulnerable to this electromagnetic energy that comes from coronal mass ejections. That we're lucky that we haven't been hit by a big one with all of our communication systems. Well, that's exactly what happened in 1989 when a powerful solar storm provoked a major blackout in Canada that left 6 million people without electricity for 9 hours. And here is the actual power grid station melted down by the electromagnetic energy from the sun that entered into it through our atmosphere. Kind of scary, isn't it? It disrupted electric power at the Hydro-Quebec generating station, and even melted some power transformers in New Jersey, shown here. This solar flare was nowhere near the same scale as the Carrington event, which was maybe 3 times bigger, the one in 1859. Then, just at the turn of the century, 23 years ago, July 14th, 2000, A Bastille Day event in France was disrupted by a major solar eruption, caused some satellites to short circuit and led to some radio blackouts. It remains one of the most highly observed solar storm events and was the most powerful flare since that Canadian flare. So that was about 11 years, no, about 20, 11 years earlier. When are these predictable? We really don't know how to predict them. That's why we got all these satellites looking at the sun all the time. It's sort of like predicting when a volcano is going to erupt. You might get some indications that there's a rumbling going on, and that's what they're trying to figure out, what's going on inside the sun that makes all this come out like this. Well, here is another major X-class flare. They got all kinds of classes to scare you with them, but X means X-rays. And this was in 2006. And it disrupted ground communications and global positioning system satellites for about 10 minutes. So can you imagine if you're flying on an airplane to Europe, big jumbo jet, 300 people on it, and for 10, 15 minutes, the pilot doesn't have his global positioning system working. It went offline, and they're trying to figure out what happened. And then they got to fly the plane manually and look at a regular compass and like air pilots used to do. Well, this is what can happen. The sunstorm in 2006 was so powerful that it actually damaged the X-ray imager that took this picture on a global weather satellite. Yes, they use weather satellites to look at the sun occasionally too. So that's one way they can tell any how much junk is in our atmosphere by looking at it obliquely. And finally, just a recent one, Marty, in 2022, last February, SpaceX launched how many satellites? They launched about 50 Starlink satellites during a warm-up of the sun caused by geomagnetic activity. It just doesn't disrupt electronics. What it also does is that energy warms up the atmosphere. And when things are warmed up, they expand. So for about a 5-day period, these geomagnetic storms warmed up the Earth's atmosphere enough that it created more drag up about 50 miles high, where these Starlink satellites go. They're released in very low orbits, from 60 to 120 miles, and then they have engines on them that raise them up to 350 miles high. All right. That's why he can use a smaller satellite booster like the Falcon 9 and get so many of them up there. These are the Pez dispensers, so to speak. They shoot out of there like your candy Pez dispenser that you're looking at down on Earth. Well, he launched 40 satellites. That's the number 40 on February 2022, worth over 50 million. And then shortly after deployment, the atmospheric drag on them as they tried to use their ion thrusters to move them up wasn't enough to overcome the atmosphere that had suddenly raised itself. It's the same principle that doomed Skylab, all right, in 1977 when it came down way too early, or 79, I think. During a geomagnetic storm, atmospheric drag absorbs energy from the storms, heats up and expands upwards, making our atmosphere denser. And this atmosphere was so dense that these satellites could not raise up to their proper orbit, and they failed to overcome the increased drag and began to fall back to Earth, eventually burning up in the atmosphere. And Elon Musk said, that's another $50 million in satellites, 60 million in launching them. We'll just write that off. So, but it does happen, and it happened a year ago. The sun causing the demise of 40 Starlink satellites. And the astronomy community cheered as those nasty satellites. They're nasty because they leave streaks of light across exposures of images and other things. Well, that's all for the sun affecting us the way it has. Thank you Connie McDaniel for suggesting that story with a news item that warned everybody that the sun was having coronal mass ejections. It has them about every week, but they don't all point to Earth, and therefore we're safe. But one time we're going to hit a biggie, and I predict our cell phones could be wiped out. We went from the cell towers to the satellites now. That's what's going on. If you've noticed, less uh, cell towers and cell relay stations on the side of hotels and so forth, like I saw a lot now Daytona Beach. But those have disappeared because of the satellite constellations that are being put up. Although Elon Musk constellations are specific for his own system out there. Well, hope you enjoyed looking at our sun. Do not look at it with telescopes, binoculars. It'll burn your eyes out immediately. But enjoy it for what it is, our warming, life-giving star. Well, if you don't know what this mission is all about, shame on you. This is our first Expedition 1 was going on November 2000 for 23 years. Space has been continuously occupied by human beings on our International Space Station. All right. We've always had Americans up there. Right now we have 2 American women, no American males. That'll be changed in March with the launch of the Crew 8, which has Barrett and another American male on it. But think about it. For 3 years, if you're 23 years old or 20 years old or have somebody, grandkids, kids that are 20, 21, 22, 23 years old, they have never breathed a breath on Earth that someone's not breathing a breath in outer space orbiting Earth. You got Sergei Krylov there. Bill Shepard was the commander, and Yuri Goudenko was the Russian up there. Both Russians, very experienced. So was Bill Shepard. This was his 4th flight. That's what the space station looked like above their heads there 23 years ago, with Zvezda Zarya and the Earth's not Harmony, Zvezda. Zarya and our unit there. Unity. Yeah, Unity. Unity put everything together there. And this is what it looks like today. Of course, you can still find the Zvezda the docking module up there at the top in what the International Space Station has become. A true partnership of human beings from, I think there's 5 different countries up there now, doing science together, getting together, eating meals together, then going on their basic tasks down the hallway, so to speak. The structure in the center is the backbone. There's nobody in that. They're all below that on the tubes here in the bottom. That's the Kibo Japanese module with the porch there that they can put things in and out with the robotic arm you see there. And then all the rest of it is infrastructure for the solar panels and the new solar panels that we have there. Go out and see the International Space Station. There's an app for that about twice a month, in the morning for about a week, and then the evening twilight for about a week. You can see it go overhead. It's quite a sight to see. The 70th expedition is going on. Coincidentally, for those of us that might be 70 years old. And there are the crewmates that are up there together, 7 of them. We should act like crewmates on Earth, not like passengers. They have to act like crewmates because they're helping each other. And quickly, we'll remind you all to go out and look at the stars over the next few nights, as the moon is not up. It's in the after midnight sky. In fact, new moon is on the 13th of this month. And but if you are an early morning riser, like I know you are, Marty, you go out and see the moon. Let's see, the 9th is Wednesday, maybe Thursday. You're going to see the moon near the brightest star in the sky, and that star is the planet Venus. Venus is just brilliant in the morning sky right now. But then it's going to be whipping around our evening sky by the 14th, and then you're going to see that come up as a crescent in our sky. And first quarter is November 20th. Well, here's a star map that you can get for free at skymaps.com. All right. And the pink, the blue is the Milky Way. Yeah, you think about the Milky Way as a summer phenomenon, but quite frankly, it's best in October and November as we get dark with Eastern Standard Time taking over. Sun is setting at 5:30 at night instead of 6:30, so it's going to be dark before supper, and the Milky Way is just gorgeous right now, and then it'll keep moving to the west, and by about 11 o'clock be gone completely from our skies. But a lot to see. The planets Jupiter. Let me notice that we have Pegasus the horse there in the middle, and the passion play of the hero Perseus saving the maiden Andromeda is all told out there in the sky that you can see there. So up in the sky right now, Larry Pusker will be going out and looking at the brightest star you see in the east, Larry, at about 9 o'clock. And of course, the higher it gets, the more apparent it is the planet Jupiter. Only Venus, the sun, and the moon are brighter than Jupiter, shown here. Not a professional, amateur astronomer like me, and a better telescope than what I own, took that with the red spot visible. There's the red spot again in another backyard telescope there. The red spot is a storm that is like a cyclone that's been happening, and you can see it's kind of pushing the clouds as it goes through it. So it's very fun to watch, and you can actually watch these cloud bands change within the hour as Jupiter moves quite frequently, and it goes around in 10 hours, incredibly. So you're only going to see the red spot there for about 3 or 4 hours as it moves across the cloud band there. Doug Forrest, glad that you're watching today. Up above at night is a bright star. It looks pretty bright. It's brighter than most stars around it. That's the planet Saturn, Doug. Gary Gerald may have seen that already. He's up there in Georgia. Cliff Watson, thanks for watching today in Pomona, Australia, and your financial contributions in support of the American Space Museum. We got Carlton Bailey watching and Mark Usiak, two great friends of each other, and now me in the museum. Space Nerds watching. Glad that you're watching, and Marina R is watching in the Ukraine. Now we got a question for you, Marina. You see the picture at the top, and you see the moonrise over the horizon. Well, if we could put Saturn at the distance that the moon is, 250,000 miles away, is that what Saturn would look like? Taking up about 17 degrees of our sky? Because the moon is 2,000 miles in diameter, and it takes up half a degree of our sky. Incredibly, 180 moons could be stacked end to end from horizon to directly overhead. Yeah, like that. There, I'll go like that. All right. Well, this is fact. Saturn would be over 17 degrees across, and the rings over 25. And if we were on Cocoa Beach, it would look like this in the evening twilight. Wouldn't that be a sight to see? So that is fact. That is Saturn if put at the distance where our Earth is, our moon is. Wouldn't that be cool to see? So, well, the only cooler thing to see is Space View Park and our shuttle monument out there. A picture I took the other day on a beautiful, clear day. The pylon on the right that you see, and the one behind the tree, and the other one's in the distance. Those are space workers like Marty Winkle that paid $100 during the construction of this. This was dedicated 9 years ago this month, with a whole entourage of astronauts there. Quite a work of art. That side of tells the story of where all the centers were that were involved with the shuttle, and then on each panel around the side, carved in granite, are different processes of our wonderful shuttle orbiters that are now in captivity in museums, and we sure love looking at Atlantis at our Kennedy Space Center. So, Marty, that's it for today. Thank you for a great Streamlabs presentation, as everybody learned probably more than they wanted to, about how the sun affects us here on Earth. Get ready for that big coronal mass ejection. You'll know it when your cell phone melts in your hand, I think. Man, it could get that bad. There could be something that intense that could hit us and just melt the transistors or whatever chips in whatever we have here that's doing electronic work for us. So, anything else, Marty? All right, we have Terry White coming on Wednesday to talk about the space shuttle as the shuttle garage manager, so to speak. The shuttle garages being the orbital processing facilities. And tomorrow we'll try to show you some pictures of the fun that some of our volunteers and Marty had out at Kennedy Space Center. They had over 5,000 people out there, I understand, Marty. Quite a big turnout. And it was a big family day, a way to get the families and everybody unifying together as the Artemis program has NASA going back to the moon. So until tomorrow, when we talk about some more space news as well as some shuttles of the month of November, I'm Mark Marquette saying we can't wait to see you in our museum to bridge the space between us. Thank you, Dave Stange. I'm putting the money on November 25th game, okay, on the Buckeyes. See y'all later.